Alright, this video I'm going to take this formula that we derived in the last video, this formula for arc length, and I'm going to apply it to a couple of problems, two problems. And it turns out to be okay once we do this. Alright, so we're going to find the arc length of y equals 2x to the 3 halves plus 3 on the interval 0 to 9. Our formula says that this arc length s is going to be equal to the integral from a to b of the square root of 1 plus f prime of x squared dx. So, first thing we got to figure out is what is f prime. So if y is 2x to the 3 halves plus 5, then y prime will be 3x to the 1 half. And just get it all in there. Y prime squared, because that's what we're really going to need here, is going to be 9x. It turns out pretty nice. So over here we've got s equals the integral from a to b, and in this case a to b is 0 to 9 of square root of 1 plus 9x dx. This isn't too bad. We can use substitution. U equals 1 plus 9x, so du equals 9 dx. So 1/9 du equals dx. So we can rewrite this, and I'll use a third color, as s equals the integral of square root of u, so 1/9 square root of u du, and we want to say, we need to know the endpoints here, so if x equals 0, then u will be 1. If x equals 9, u will be 9 times 9 is 81, plus 1 is 82. So we're going to be going now from 1 to 82 because we changed the variable from x to u. Okay, pretty straightforward now. We've got s equals 1/9 times, and this is u to the 1 half, so we're going to need 2/3 u to the 3 halves, right, from 1 to 82. If I scroll down a little bit, I've got s equals 2 over 27, 82 to the 3 halves minus 1 to the 3 halves. And that turns out to be, hold it, got it written down, 54.93. Check that one on your calculator to make sure, but I think that's right. I've checked it a couple times now. Alright, so there we go. Use that formula. Alright, I'm going to do another one. Same thing here. I've got find the arc length of y equals 1/2 e to the x plus e to the negative x on the interval 0 to 2. So again, s is going to be the integral of a to b, from a to b of the square root of 1 plus f prime of x squared dx. So y equals 1/2. I'm writing it as 1/2 instead of 0.5. I hope that doesn't confuse anybody too much. Y prime is going to be 1/2 of e to the x, minus e to the negative x. Doing that a little quick. I don't think I'm making any mistakes though, but it would be the first time, so you might want to double check that. Okay, so let's go with red. Oh yeah, we want to figure out what this is squared too, right? Because we're ultimately what we need is f prime squared. So if we square this, we get 1/4 and e to the 2x. I'll do this whole thing here. E to the x, e to the negative x, plus e to the negative 2x. And if I simplify that, I get 1/4 e to the 2x minus 2, right, e to the x minus times e to the negative x is just 1. So minus 2 plus e to the negative 2x. And keep going. Alright, so here's my y prime squared. Now I can write up my my arc length. Okay, integral from, what were my endpoints? Interval is 0 to 2, so from 0 to 2 of 1/4 times e to the 2x minus 2 plus e to the negative 2x. This looks uglier than it is, really, because the 1/4 is just going to come out front. You don't need to worry about that. And each one of these parts can be integrated individually. E to the 2x, the antiderivative is we get e 1/2 e to the 2x. Negative 2, obviously the integral. Did I miss a negative here somewhere? No, I don't think so. Negative 2x, and then this will be negative 1/2 e to the negative 2x. And we're going from 0 to 2. Alright, so I get here, and then I've got s equals 1/4. I put my 2 in, 1/2. So let's do for 2, 1/2 e to the 4th minus 4 minus 1/2 e to the negative 4 minus, what am I going to have? I'm going to have 1/2. Well, e is going to become, this will be 1, this will be 0, this will be 1. So I have 1/2 minus 1/2, obviously just 0. So I get 1/4 times this whole thing, and I've checked this 100 times now, and I feel fairly confident in saying that it's 5.82 is our final answer. Alright, so that's it. That's how you find arc length, the arc length of a curve.